Let's talk about ECG interpretation. I know lots of you guys find it difficult to interpret ECG. See, you mustn't be an expert in interpreting ECG, but at least you must know the basis of ECG interpretation, at least to know when the ECG result is normal and when it's not normal. This will help you to nurse your patients effectively. Now, what is ECG? ECG is an electrocardiogram that monitors the electrical activity in the heart. This electrical activity facilitates the blood flow through the heart and also facilitates the distribution of blood through the body. Now, for the basis of ECG interpretation, at least you should be able to know the normal blood flow through the heart and the electrical activity through the heart as well. That's where you talk about the SA node, the AV node, and all that. Let me just take you back to blood flow through the heart. See, I'm not here to teach you anatomy. As a nurse, you must have known your anatomy and physiology. The heart should be number one, right? So I will just give you a quick overview of the blood flow through the heart. This is the diagram of a heart, right? Here you will see the four chambers. You will see the right atrium, you see the left atrium, you see the right ventricle, you see the left ventricle. The right side of the heart controls deoxygenated blood without oxygen. And the left side of the heart controls oxygenated blood, that is blood enriched with oxygen. Now, how does blood flow through the heart? All the deoxygenated blood moves into the right atrium through the superior vena cava and the inferior vena cava. The right atrium empties blood into the right ventricle, and from the right ventricle, this blood moves to the pulmonary arteries for oxygenation in the lungs. Then this blood moves from the lungs through the pulmonary vein to the left atrium. From the left atrium, the mitral valve opens and it moves into the left ventricle. From the left ventricle, it moves through the aortic valve to the aorta for systemic circulation. Now, why do you need to know about blood flow through the heart in order for you to understand ECG interpretation? You need to know that because ECG interpretation comprises of just three things. One is atrial depolarization, which is atrial contraction. Two is ventricular depolarization, which is ventricular contraction. And the third one is ventricular repolarization, which is ventricular relaxation. When we talk about electrical activity, which is the ECG we are talking about, you should talk about the SA node, the LV node, the bundle of His, and the Purkinje's fibers. How does this play a role? First of all, the SA node controls the atrium. That is why it's called sinoatrial node. When the atrium is filled with blood, the SA node sends impulse to the LV node, that is the atrioventricular node. And from the LV node, these impulses will be sent through the bundle of His to the Purkinje's fibers, which is around these muscles. This is the Purkinje's fibers. These fibers will help to push blood from the ventricles to the aorta for systemic circulation. So if anything interrupts this electrical activity or electrical flow through the heart, this is where arrhythmia, dysrhythmia comes in, where you see atrial defibrillation, ventricular tachycardia, ventricular fibrillation, and all those stuff. I don't know if this makes sense a little bit. Just know that the electrical activity of the heart involves three steps: atrial contraction, followed by ventricular contraction, and followed by ventricular relaxation. Each cycle makes up these three steps. After the ventricular relaxation, which is the third step, another cycle will now start again. Okay, so that is all you need to know about the electrical activity. The SA node, the AV node, the bundle of His, and the Purkinje's fibers. These four things helps in the electrical flow through the heart. So let's look at the properties of an ECG result. So when you're reading an ECG strip, you want to make sure you identify all the landmarks on an ECG strip. This is very, very important. This will help you to identify when something goes wrong on a particular landmark. What are the landmarks? We have the P wave, we have the QRS complex, we have the T wave. Okay, we also have the PR interval, we have the QT interval, and we have the ST segment. These are important landmarks you need to know when interpreting an ECG. If anything goes wrong in any of these landmarks, this indicates that something is wrong. Normally, this landmark should be like this. My next video, I'll be coming with real ECG results, where I'll be showing us how to identify normal ECG strip and abnormal ECG strip. Okay, so for this, we'll just use this diagram to learn the landmarks in an ECG. So we have the P wave, this is the QRS complex, this is the T wave. Then the PR interval, this starts from the beginning of the P wave to the beginning of the Q in the QRS complex. This is just the QRS complex, okay? For the ST segment starts from the end of the S in the QRS complex to the beginning of the T wave. This is the T wave, so this is the beginning of the T wave, Okay, for the QT interval starts from the beginning of the Q till the end of the T wave. I don't know if that makes sense, but these are important landmarks you need to note in an ECG strip. P wave, QRS complex, T wave, PR interval, just like I said, this is what is being listed here. Do you know that each of these landmarks indicates that something is going on in the heart? I mean the P, Q, R, S, T waves. For the P wave, the P wave is known as atrial depolarization, that is atrial contraction. Here, the atria and the upper chambers of the heart contract in order to push blood into the ventricles. When it gets to the ventricles, that is where the QRS complex plays a role, okay? The QR complex is known as the ventricular depolarization, that is ventricular contraction. Here, the ventricles contract in order to push blood out for systemic circulation. After that, the next one is the T wave. The T wave is just like ventricular repolarization, that's ventricular relaxation. This is just like a resting phase, just the heart trying to prepare or trying to refill for another heart cycle to start again or another heartbeat to start again. Okay, this takes about few seconds. It's not like it's going to take few minutes for you to refill. Just within few seconds, just just the circulation. So this is what happens during these PQRST waves. I don't know if that makes sense. It is important for us to note these landmarks because this will help us to identify where something deviates from normal. When you see a normal ECG strip, you should have the P wave, the QRS complex, and the T wave. In this way, also in our next video, I'll be telling us the normal range, the normal timing. This will help us to know when something is wrong with the shape, with the size, with the length, and all that. To wrap it up, just know that a typical ECG is made up of PQRST waves, okay? In the P wave, there is atrial contraction. In the QRS complex, there is ventricular contraction. And in the T wave, there is ventricular relaxation. After ventricular relaxation, another cycle will set in. If you find this video helpful, like this video, comment, and also share with your friends so that they can also learn as well. I will see you guys in my next video. And don't forget to click on the subscribe button. Bye.